Hello students, in this video we can see here RLC series circuit is given and a unit step signal is applied as input signal, and because of this voltage a current is flowing, that is IT. So here we have to find two things. First, whether this response is underdamped, overdamped or critically damped, and the next portion we will find these three parameters. So first we will check this input signal, which is a unit step signal. So we all know that at time t less than 0, unit step signal is nothing but 0, and at time t greater than 0, this unit step signal is 1, or we can draw its response as, if this is time t and this is t less than 0, so it remains 0 volts, and for the time t greater than 0 it becomes 1. This is our unit step signal. So at time t less than 0 this will become 0. So voltage applied to this circuit will become 0 volts, and at time t greater than 0 this will become 200 volts. Okay, you can assume that this unit as a volt. Now we can conclude from here that this unit step signal is working as a switch for this circuit. At t is equal to 0 it is supplying no energy to the circuit, or it is not, as it is not connected to circuit, and at t greater than 0 it is supplying energy or voltage to the circuit. So it is working as a switch for this circuit. Now we will write KVL at time t greater than 0 to find its type, whether it is underdamped, overdamped or critically damped. Okay, so write KVL. So in our solution, first we will write KVL at t greater than 0. So at t greater than 0 our input is 200 and drops are Ri plus L di by dt plus 1 by C integration I dt. Okay, these are the drop across resistance, inductance and capacitance. Now we will remove this integration sign by differentiating this equation. So differentiate with respect to t this equation. So here we will get 0 R di by dt plus L d2I by dt square plus I by C. Okay, now we can write this term first, this term as second term. Okay, so here we can change this d2I by dt square with coefficient this plus R di by dt plus I by C is equals to 0. Okay, divide this whole equation by L so that coefficient of this will become 1 LC. Now this is the format where we can change this double integration by sign d square plus R by L d plus 1 by LC and with I as a common is equals to 0. Okay, from here this is our characteristic equation, and we will find the roots of this characteristic equation, and these roots will decide whether it is underdamped, overdamped or critically damped. Okay, if roots are equal and real, then it is critically damped. Okay, if roots are real and equal. Okay, if roots are real but they are distinct, not equal, then it is overdamped. Okay, for this overdamped, roots of this characteristic equation are real and distinct. Okay, and for third, under damped situation or under damped response, roots will be complex. Okay. If roots are real and equal, okay, write down real and equal, then the response will be critically damped. Okay. So on the basis of the roots, we will decide whether it is critically damped, this is first type, it is over damped, or it is under damped. Okay. So first we will find the roots of this. So here will be two roots, D1 and D2. And these roots are, we can find using formula minus B plus minus under root B square minus 4AC divided by 2A, that is 2. Okay, so divide each term with this 2, that is 2L, and this will be cancelled by this 2 because here is a root, so this 2 will become 4 here. 4 will be cancelled by this. Now we can write this as 1 by under root LC whole square. Okay. Suppose this term is alpha and this term is again alpha. This is omega naught. Okay. Write down here. Alpha is equals to R by 2L and omega naught is equals to 1 by under root LC. Okay. If alpha and omega naught are equal, then roots will be real and equal, because this term will be, if they are equal, then this term will become 0. If alpha is greater than omega naught, then second condition, roots are real and distinct. But if omega naught is greater than this, then this under root will become will create a complex quantity, and this response will be under damped. Okay, so here first, now we will check the value of alpha, that is R by 2L, that is equals to, here R is 200 and L is 0.1, so this is equals to 1000. Now check the another parameter, that is omega naught, and it is equals to 1 by under root LC, that is under root 0.1 into 10 microfarad. So this will again become 10 to the power, this will be cancelled, minus 6. So it is again 1000. So here we can see that this alpha is equal to omega naught. If alpha is equals to omega naught, then this term will become 0. So roots are real and equal. Okay. So this is the condition for critically damped. So we can say, since alpha is equals to omega naught, therefore our response is, you can say the response is critically damped. Okay, in this way we can find the response type. Now we come to the next part of our question, that is find these parameters. Okay, for this we will first find the initial condition, and initial conditions are written at time t less than 0. We know that at time t less than 0, this ut is 0. So input voltage is 0 volt. That means no energy is supplied to the elements of the circuit at time t is equals to t less than 0. So at initial, so we will find first the first initial condition, that is IL 0 minus. Since no current is supplied, no voltage is applied to the elements, so this will behave as a open circuit and this will behave as a short circuit at time t is equals to 0 minus, and this will be same as IL 0 plus, or you can say this I 0 current is same as IL 0 current, okay, because they are in series. So these three currents are equal and they all are 0 because it is now open at time t is equals to 0 minus, or you can say at time t is equals to 0. Okay, so this I0 is equal to 0 ampere. This is our first parameter. Okay, now the second initial condition is the voltage across capacitor at time t is equals to 0 minus. This is this will become short circuit, so it's a voltage, that is, you can also write it VC 0 plus is equals to nothing but 0 volts. Okay, so this voltage is 0 volts. Now we will use these two initial conditions in finding these parameters. Okay, here at time t is equals to 0, we have written this KVL at t is greater than 0. Now at t is equals to 0, or you can say at t is equals to 0 plus, we will write the different values. Okay, suppose this is 200 is equals to R I 0 plus L di by dt 0 plus plus this is nothing but voltage across capacitor at 0 plus. So we will write it like this: voltage across capacitor at 0 plus time. We know that I0 plus is, this I0 plus is 0 ampere. So substitute, this is equals to R multiplied by 0 plus L multiplied by this di by dt 0 plus, and this VC0 is again 0. So here we can find the value of di by dt at 0 plus. Okay, at t greater than 0, this will become 200 divided by L, and that is 200 divided by 0.1. So it is equals to 2000 ampere per second. This is our parameter di by dt. VL0 plus, voltage across inductor is VL0 plus, and since this inductor is open circuit at time t is equals to, at t less than 0, inductor is open circuit, so all the voltage at t greater than 0 will be dropped across this inductor. Okay, so at t greater than 0, this voltage drop across this is 200 volts. No current would be flowing, but voltage, this whole voltage will be dropped across this at t is greater than 0. As soon as we connect this 200 volts, this will be dropped across this. Okay, so voltage VL0 plus is equals to 200 volts. Okay, that will be equal to VL0 minus, because inductor and capacitor don't change their status immediately. Now the third parameter is I infinite. At infinite time, when this 200 volts voltage is applied to the circuit, this will behave as a short circuit and this will start behaving as open circuit. Now since there is an open circuit, so this current will again become equal to 0 because current cannot flow in an open circuit, and this capacitor will be opened at time t is equals to infinity. So here I infinity is nothing but 0 ampere. So we got all the parameters. First is 200 volts VL0 plus. Second parameter di by dt 0 plus, that is 200,000, and third is 0 ampere. So this is the way to find all the parameters at time t is equals to 0 plus and t is equals to infinite. First we will find initial condition at t less than 0, that is current through inductor and voltage across capacitor. These are two initial conditions, and IL0 minus and IL0 plus will be same. Similarly, VC0 minus and VC0 plus will be same because inductor and capacitor, their status remains same just after and just prior to switching. So at t is equals to 0 minus and t is equals to 0 plus, the status is same, so the values will be same, and that value we will apply at KVL at t greater than 0